Shores, Surfrider, and the Pink Tides Project. I'm Philip Johnson. I am the Shoreline and Land Use Manager for the Oregon Shores Conservation Coalition. We are by no means a new organization. We have been around more than 50 years. Indeed, we evolved out of the citizen campaign that created the Beach Bill, which gives us our entirely public shoreline. We work on the full range of conservation types of issues. We work on land use planning, water quality, shoreline management, marine conservation, endangered species. We've been heavily involved in measures to protect estuaries and rocky habitats lately. Many people know us best for the Coast Watch volunteer program, through which people monitor mile-long segments of our outer shoreline. We can always use additional Coast Watch volunteers. I'd also like to put in a pitch for our Land Use Scouts program, through which people monitor local jurisdictions, cities and counties for land use activity to give us an early warning so that we can be most effective. If you would be interested in that, by all means, get in touch with me. You can reach me at Philip with 2 L's at oregonshores.org and learn more about Oregon Shores on the website, oregonshores.org. So Oregon Shores and the Surfrider Foundation have joined forces to create what we call the Oregon Beaches Forever campaign. We've both been dealing for years with the sort of incremental loss of the natural shoreline to shoreline armoring. We've increasingly become aware, though, of the broader problem of what's sometimes called the coastal squeeze, as sea level rises and storm surges become more intense and then bump up against hardened shoreline armoring structures, which cut the beach off from its sand supply. So to try to address that long term, we've created this campaign. We've got much to do to educate ourselves and all Oregonians on the problem and on the potential planning and legal issues involved in trying to address it long term. Meanwhile, though, we're also collaborating on more immediate issues where we can at least ameliorate the problem. That would include local processes, city and county. So, for instance, we're working together on the Clatsop County Comprehensive Plan update right now to push them into taking into account sea level rise and the coastal squeeze and plan long term for that. And another way we can work together in the shorter term is on the Oregon Parks and Recreation Department's rules when it comes to permitting shoreline armoring. There is a rulemaking process coming up, keeps getting pushed back, but hopefully we'll be starting sometime later this year, and we will work together on that to get the strongest possible rules addressing shoreline armoring. With that, I will go, pass this on to my colleague with Surfrider, Kaya Hazard, and she can say more about Surfrider and where we're going.
Thanks. Thanks everyone again for being here tonight. My name is Kaya Hazard. I'm the Oregon Regional Manager with the Surfrider Foundation. If you don't know about Surfrider, we're a nonprofit working in coastal states nationwide, and we work on many different initiatives to protect our ocean and coastline. So these range from issues like water quality, protecting special places like Oregon's marine reserves and rocky habitats, fighting against plastic pollution, both through programs like our beach cleanup program, as well as through legislation, such as plastic bag bans, and making sure Oregon's beaches remain accessible. And yeah, we're really excited to be launching the Oregon Beaches Forever campaign. In addition to continuing to oppose shoreline armoring and all of the other avenues that Philip described, we'll also be working to implement nature-based solution model projects and policies that promote beach preservation and climate adaptation. So if you would like to learn more about the campaign, that link in yellow will take you to a bit.ly page where you can get to the Surfrider website, you can get to the Oregon Shores website, and there are some other helpful links housed there where you can learn more about the campaign and learn more about our other upcoming events. We will be hosting monthly webinars through the end of the year and into next year. So if you would like to RSVP for any of those, you can find those links there. And I will pass it off to Rhiannon next.
Thanks, Kaya. I'm Rhiannon Bazor. I'm the Coastal Shores Specialist with the Oregon Department of Land Conservation and Development. I'm also the co-lead, along with Jesse Jones from Coast Watch, for the Oregon King Tides photo project, in which we ask our visitors and residents and anybody along the coast to take photos of king tides and help us document what sea level rise may look like in the future. So those king tides are coming up soon, so check out our social media and our website, OregonKingTides.net, for more information on that. It is my pleasure and honor to introduce our guest speaker tonight, Dr. Gary Griggs. Can't talk today, sorry. Gary is a distinguished professor of Earth and Planetary Sciences at the University of California in Santa Cruz, where he has taught for 56 years now. He received his PhD in oceanography from Oregon State University in 1968. His research, teaching, writing, and lectures have all focused on coastal processes, hazards, and the impacts of and responses to sea level rise. And in 1998, he was given the Outstanding Physical and Biological Sciences Faculty Award at UC Santa Cruz, and the Alumni Association honored him with a Distinguished Teaching Award in 2006. The California Coastal Commission and Sunset Magazine named him one of California's coastal heroes in 2009. And Gary chaired a committee in 2017 recommended by California Governor Brown to update California's sea level rise projections. He has served as director of the Institute of Marine Sciences for 26 years and led the development of Coastal Sciences Campus, in addition to writing 14 books. And on a personal note, Gary was my master's degree supervisor and a career mentor, and so this is a really cool moment for me to get to introduce him. So thank you, Gary, for being here, and thank you everyone for joining us tonight.
Great. Thanks all three of you for inviting me tonight. And Rhiannon, congratulations on your career track, which has been upward. So we'll see if we can, did that picture come up? We change? Okay. As an admission, even though I've lived in California most of my life, Oregon is my second home in a sense. When I was quite young, 7 or 8 years old, my parents thought Southern California was too crowded, so they bought a farm in Southern Oregon, and so we moved to Oregon for a couple of years. And people say, where? Well, it was south of Grants Pass, midway between the town of Wilderville and Wonder, which are two tiny little gas station towns. And then I came back to OSU for graduate work. So as a kid, we spent a lot of time on the Oregon coast camping and hiking. And so I have a connection. And so this is kind of an honor to be asked to give this talk. So trying to set the big picture first, there's 3 things that sort of have a large effect on what's happening with the Oregon coast today, that not knowing all of you who are listening and your backgrounds, I'll just assume you have graduate degrees in geology and oceanography. So certainly the tectonic setting. We now know Oregon's coast lies at a boundary between 2 colliding plates. Globally, climate is changing as the Earth gets warmer, sea level rises because ice is melting. And then over the short term, which could be 50 years or longer, threats to the shoreline are typically very large waves arriving simultaneously with very high tides, often during El Nino events. So when I went to Corvallis in 1965, I had no idea what I was going to do for graduate work, but what came out of that was really an interest and connection to both climate change and tectonics. So many of you may know that off the coast of Oregon, a number of miles offshore, is this deep sea channel, sort of a submarine extension of the Columbia River that had never been studied before. So we would steam 200 miles offshore from Corvallis, often in weather that wasn't great. And then we were taking deep sea sediment cores, 10 to 12,000 feet of water, and bringing back those sediment cores and then analyzing them. And 2 of the important things that came out of those, one was that climate change, I realized then, was a thing that had gone on forever, as long as we've had an Earth and a sun. And we could tell by the types of fossils preserved in the sediment cores, and we had those from cold water and warm water that oscillated. So back then we knew about climate change. The other thing I'll talk about in a minute is we also learned about, before plate tectonics was a thing, we learned there had been some major events that affected the coast of Oregon. So this is a good way to collect sediment that maybe takes us back 50 or 100,000 years. And by methodically going through these cores, we could pull out a lot of history. And we now know climate change has been recorded at the deep end from ocean drilling going back about 65 million years. And there's a number of indicators in the cores that have been drilled how climate has changed. We've now gone into the ice in Antarctica, about 2 miles down, and gone back about 850,000 years and can detect climate change. Southeastern California, we have these bristlecone pines that live as much as 5,000 years, and their tree rings record climate change. And actually in the deep sea off this area, we have deep sea corals, not coral reefs, but solitary corals that have a stem, and that stem records climate changes in the overlying water, and they can live up to 5,000 years. So climate change has been recorded broadly around the planet. We have a pretty good understanding today of what has happened and are beginning to project that into the future. So why is has Earth's climate change occurred? There was a major event that occurred not long after the Earth formed, and it turns out we were hit by another small planet, maybe the size of Mars, when both planets were somewhat molten. And what that did was actually threw the Earth off its vertical axis, so it has a tilt, and that tilt changes over about 41,000 years, and that gets us a little closer to the sun, a little further from the sun. The Earth has a wobble on its axis that has a cycle of about 26,000 years. It does much the same, takes us a little further away, brings us a little closer. And then the Earth's orbit around the sun is not a circle, but it's an ellipse. Similarly, the orbit of the moon around the Earth is an ellipse, and that's why we get these king tides when the moon is closer, which it is now. So these three together have given us climate change basically over the history of the Earth. This is what we now believe happened about 4.4 billion years ago when this planet, small planet, when it was molten as was the Earth, collided and sort of threw us off our vertical axis. So we've known about climate change for a long time, and we give a lot of credit to some more recent discoveries, but in fact, it was a woman, Eunice Foote, in 1856. At that time, women were not really, unfortunately, recognized as scientists. They couldn't publish in journals, but she showed with some experiments that carbon dioxide traps heat from the sun through the greenhouse effect. So the natural greenhouse effect from the carbon dioxide, methane, nitrous oxide, ozone produce an average global temperature of about 60 degrees Fahrenheit. Without those natural greenhouses, it would be 0. So the natural greenhouses are very important, but what has clearly happened since the Industrial Revolution back in the late 1800s is we've been putting more and more greenhouse gases, particularly carbon dioxide from burning fossil fuels, into the atmosphere. It's increased now by about 50%. And you can see the blue line is parts per million of carbon dioxide, and the white line is global temperature. Sea level is also intimately related to global temperature. So if we go back, say 24,000 years, we were at the end of the last ice age. And this is part of these global cycles of the relationship between the Earth and the sun. The Earth was beginning to warm up again. And what happened is it warmed was ice melted. So those glaciers and ice sheets on the continents began to flow into the ocean. So between about 18,000 and 8,000 years ago, sea level rose pretty dramatically, maybe half an inch a year, 45 inches per century. But in fact, within that period of about 10,000 years, from 18 to 8,000 years ago, there were some periods when it rose very rapidly. An inch per year we could sit out there and watch that. And we believe now that these are due to Antarctic ice sheet collapses. So 8 feet per 100 years. About 8,000, 7,000 years ago, sea level leveled off. In a natural sequence of events without human production of greenhouse gases, we were at the end of a warm period, sea level had risen, it would start to go down again. But for roughly 7,000 or 8,000 years, it has been relatively level, maybe less than a millimeter per year. And interestingly, that happens to coincide with virtually the entire history of human civilization. So we've never had to deal, as humans, civilization, with sea level rise. Today, it's rising over the last decade or so at 4.4 millimeters per year, about the thickness of 3 or 4 quarters, or 17 inches per century. But we know that's accelerating. And so the question is, how fast is it accelerating, and where will sea level be 10 years in the future, 20 years, 50 years? So although we had tide gauges around the world that were measuring sea level rise for over a century, those are relative to land because we cite those on piers or wharfs or breakwaters or bedrock, and we measure it relative to land. So if the land is rising or sinking, we're going to get a value of sea level rise at that particular location. I'll talk a little bit about Oregon here. But in 1993, we launched several satellites, and we began measuring at absolute sea level rise from space, which these satellites have to know exactly, we have to know exactly where they are, down to hundredth of a millimeter. And they're essentially circling the Earth, sending down, radar beams to the Earth or the ocean surface and measuring sea level rise over time. So we can see it's accelerating. It's now again up to 17 inches per 100 years. So if we look at the California coast, we have maybe 12 tide gauges. These are kind of color-coded, showing how high, how fast it's rising. And most of these are on the order of a millimeter or 2 per year. However, as we get to Cape Mendocino, and from there all the way through Oregon and Washington, the nature of the tectonics changes, and you can see, say, Crescent City near the border, sea level is actually dropping relative to land based on the tide gauge. So what happens at that point? We've actually moved from most of California, where these two plates are moving alongside of one another, not up or down. We call that a transform boundary. And then off Oregon, these two plates are colliding, which has a lot of implications for the coast. So when we look at Oregon's numbers, these are the 5 main tide gauges. We can see, so sea level is rising at 4.4 millimeters per year. Two places here, Southern Oregon and up by Astoria, sea level is dropping. Dropping because the coastline is rising faster than sea level is. So relative to land, sea level is dropping. It's not a concern. A few other places in the middle, it's rising slower than the global rate, which means the land is also rising. And then Tillamook is the fastest rate. So a little bit of variation, but what it does show is the California or the Oregon coast, like much of California, is rising. So there's both short and long-term changes which affect the shoreline and beaches. This is the tide gauge at Astoria. Goes back to 1925, so a century. And the record shows its sea level is dropping slightly. And that's because relative to land, the land is rising. So it's rising faster than sea level is. In South Beach, down near, well, in the Southern Oregon coast, it's rising a little faster, but still not as fast as global sea level. So the land along the Oregon coast, for the most part, is rising. And these events you can see that isn't a nice smooth trend, but there are these peaks in here. And these happen to correspond to El Nino years. So 1982, 83, 97, 98, 15, 16. So these are short-term changes, which are much greater than this long-term change. So this is 30 centimeters or a foot. And we can have a foot of elevated sea level, which is like, more than 100 years of long-term sea level change that affect the shoreline. So the other part of my thesis work was actually the part that revealed for the first time that great earthquakes had affected the area, the Oregon coast. And to make a long story short, as we put the core into this channel, a couple hundred miles offshore, most of those cores showed a sequence of essentially what are submarine mud flows. We call them turbidity currents. And because they settle out of suspension, they're graded. The coarsest materials at the bottom and the finest materials at the top. And then we get a sequence of what we call clay, hemipelagic clay, that's been settling out of the water column. So as we look down these cores, it turns out these submarine mudflow deposits were on the order of 2 to 3 feet thick. We could date them by using both carbon-14 and also the first occurrence of volcanic ash from Mount Mazama, Crater Lake. And it turns out these events occurred every 300 to 500 years. At the time, which was 1968, we did not have plate tectonics. That's like saying we did not have iPhones and computers, but that's the way life was then. So as I finished my thesis back in 1968, I was trying to figure out why these massive mud flows would come out across the shelf, down the slope, and then run for 800 or 900 miles along the seafloor. And I could only think of two things: the sediment from the Columbia River got out to the edge of the continental slope, piled up, became unstable, collapsed, and it flowed down, or maybe big earthquakes. So I remember very distinctly going up to the geophysicists in the department who studied earthquakes and so forth. And I said, is there any reason that we should have big earthquakes off Oregon? And I remember to this day, they said, well, not that we can think of. So within that year, we developed the concept of plate tectonics. And what was confusing was, this is the area we're talking about, really, Oregon, was that most places around the Pacific that we now know are where two plates are colliding, we have trenches. We have the Aleutian Trench and the Japan Trench and the Middle America Trench. And the confusing thing off Oregon is there is no trench. And there could be a couple of reasons for that. But what we do see is this is a place where two plates are colliding. The ocean plate is going down under the continent. And as we go down below Cape Mendocino, the two plates are sliding alongside of one another, the Pacific plate, the North American plate. So a cross section could be across the Willamette Valley, Central Oregon. So offshore, we have these two spreading centers where hot volcanic material is coming to the sea surface or the sea floor, spreading out in both directions, the Juan de Fuca Ridge and the Gorda Ridge. So coming up from inside the earth, it then spreads laterally, creating new seafloor. As it collides with the edge of Oregon, it then descends. And as it descends, it's scraping along the overlying plate. Earthquakes are forming. At a certain depth, these materials begin to melt, and those fluids come back to the surface as the volcanoes of the Cascades. And this happens all around the Pacific. But this is where things get interesting along the continental shelf and the slope and the shoreline, because the plate's going down, it's sort of stuck here. And that happens, it's actually bending down the offshore area and pushing up the coastline. So this is why, and this will happen for maybe 300 to 500 years, until finally the strain is such that that breaks, the overlying plate, which has been pulled down, rebounds. This produces a pulse of water that might be 10 or 15 or 20 feet high. That's the tsunami that then moves onshore within minutes and moves offshore across the, Pacific, where it'll reach Japan in maybe 8 hours. So from a lot of studies along the coastline and the estuaries, we now know the last major earthquake, we actually know the date, in January 1700, because of a monastery in Japan that recorded this. Normally their tsunamis come with earthquakes, but there was no earthquake, so they called it the orphan tsunami. So we're now 324 years into this cycle. This could happen tomorrow. It could happen in 50 years or 100 years. So we know the evidence quite well, and you living there would for sure. Nisquam Beach is one example where we see the trunks or the stumps of these trees that as the coastline subsided, their roots were exposed to salt water, so they died and were preserved. And we can core those trees and get back to about 1700 when we know they died. So that sort of discovery, the uncertainty about the future of the Oregon-Washington coast, led to a whole series of books, which is sort of the big uncertainty now is when will this next event occur? And sort of the importance here between hazard and risk. Hazard is a process that's destructive. It could be an earthquake, a tsunami, a flood, and risk is the threat to society, the threat to the Oregon coast or Northern California or Washington. So that's a combination of the product of not only the potential damage or destruction that would be produced by that hazard, and also the probability of that happening over some time period. So some things, the probability is really high, but they're, the threat is low. This mega earthquake, magnitude 8 or 9, and the associated sort of threat is very, very high. But if it only occurs every 300 to 500 years, how do we plan for and adapt to that hazard? And this is a huge problem, as I think you all know. So while tectonic activity will go on forever, the subduction of this plate, sea level rise is going to go on for centuries. Over the near term, say by 2050 or 2100, not that we wouldn't have a huge earthquake, at least in California and I think Oregon, it's going to be these short-term extreme events that are going to pose the greatest risk to the beaches and the bluffs of Oregon. So these are large waves arriving simultaneously with very high tides or other elevated water levels like an El Nino. Those are going to happen much more frequently. And I pulled out a paper by a couple of Oregonians, Paul, who was at OSU for many years, and Jonathan Allen, who's been with the state for many years. And from this paper, it talks about how much sea level can be elevated over the short term by warmer ocean temperatures because the ocean expands as it warms, the storm surges and high tides. So we can have levels of water over 5 feet above predicted during one of these events. So much greater than a few millimeters per year of sea level rise. Fortunately, we don't have hurricanes because they can get storm surges of 10 to 15 feet, which is what Florida and these southeast states have been dealing with. So the two geomorphic environments, in my view, that are most at risk along the Oregon and California coasts are those low-lying areas, the beaches, the dunes, the estuaries, the bays. And this is one of those ghost forests that was subsided to below sea level, the roots of the trees, and they died. And then the cliffs and the bluffs. This happens to be Oregon. This happens to be California. So tied into those short-term changes, we now know from years of sort of oceanographic observations that the coastal climate, waves and storms, varies over time, over decades, and they're now been called Pacific Decadal Oscillations or PDO cycles. So this is going back to 1854 to the present. These are usually a decade or two long cycles. And we know, for example, that from roughly the mid-1920s to about the 1940s was a warm, stormier, more El Nino event cycle. And then it cycled to a cooler, generally calmer period with fewer big El Ninos. And then in 78, it switched back to a warmer, stormier cycle, and we've had a number of El Ninos. And then back to a cooler cycle about 2000. So whether we're in a warmer or cooler cycle has a lot to do with wave impacts on the coast, which way direction the waves are coming from, and also incidence of El Ninos. So interestingly, both California and Oregon went through periods of rapid population growth. This happened sort of after World War II, from the mid-40s to the late 70s. So this is the California population. You can see from 45 to 78, the increase in population. So we went from 7 million to 25 million in that period. Oregon a little different because not so populated, but still that was a period of rapid population growth. But when you look at the PDO cycles within which that growth occurred, it was a cool, calm cycle. So people built in places that looked like they were stable at the time. We built on beaches, we built in the dunes, we built on bluffs and cliffs. And then in 78, it flipped again. People began to experience things that they had not planned for. This is a plot that looks very similar. So these are ENSO, or El Nino Southern Oscillation events. And this is a dimensionless sort of a parameter that we're judging. And this has to do with a lot of different measurements we can put together. But you can see the 82-83 event, which probably the biggest in 50 years, the 97-98, 2015-16, that again fit into those stormier Pacific decadal oscillation cycles. So on top of that, a couple of recent studies indicate that waves are getting larger. This would be consistent with climate change because as the ocean gets warmer, more evaporation, more moisture in the atmosphere, greater winds create the waves. So we've got Mavericks, you've got Nels Scott Reef. So surfers are really happy about this. I think people that live on the coast, not so happy. So if we look at the shoreline, there's really these two different sort of processes or environments to focus our energy on. One is cliff and bluff erosion. This happens to be not far from the university campus in Capitola. This is a one-way cycle. When the cliff erodes, when the bluff erodes, it doesn't come back. Beach erosion, on the other hand, can be both seasonal and long-term. So this is a beach that two of our hosts may recognize. It's a beach next to the lighthouse. This is a typical summer photo at the top, an El Nino stormy photo at the bottom, and then the next summer it comes back again. So that's expected. So any stretch of coast, and I'm showing Oregon here, Lincoln City, where we're seeing bluff retreat, which is a one-way process. It's a battle between the wave energy, the tidal elevation, so where those waves will hit the coast and how often, and what makes up the cliffs or the bluffs. And you can see we might have something very hard like granite, or we can have, weakly consolidated materials and then unconsolidated materials. So this to me looks like it's not rock. And clearly the waves are winning the battle here, even though we put in some riprap and looks like some, concrete barriers. The ocean is winning here. Again, this looks like it's built on a sand dune. The foundation piers are being undermined, so that's not going to withstand much wave attack at a high tide. California has its share of cliff erosion, and this sort of runs from one end of the coast to the other. Dana Point, Capitola, UC Santa Barbara, where students live, and these have now been taken down. Part of this has been demolished. And Pacifica, south of San Francisco, these apartments have now been demolished, despite the fact that attempts were made to protect them. So cliff and bluff erosion, and then beach erosion. So these king tides can wash into low-lying areas, erode the shoreline as well. Nesquin in 2008, this picture's been around a lot. Obviously, these were not built at an elevation above the high tides and storm waves. There's a couple of sites that you can use to sort of look into the future and what sea level might do to the shoreline. So this one, I just happened to pick a low-lying area of Astoria, and the site is called Surging Seas. It's put out by Climate Central. NOAA has another one called, I don't know what it's called, Rising Seas. And so you can take any area. This is using the most up-to-date land elevations using LiDAR, and we can see the present shoreline. And then we can go over on the side here, and we can raise sea level above the highest tides by 1 foot. Whenever that happens, maybe by 2050, maybe sooner. So what you can see is anything in blue is now going to be flooded. Anything in green is below that level, but it's protected by a levee or a seawall or something. So just a single foot above high tide, the highest tide, is going to impact this area. We can go to 3 feet. We could go to 2 feet. And you can see, I don't know if this is the Astoria airport, but it's mostly underwater. This whole peninsula is underwater. We can go to 5 feet, and then it gets scarier. So we can do this any place on the Oregon coast. California suffers the same problems. These are 2 sites near Santa Cruz where very high tides. It's sort of giving us a look at what the future might look like with with a higher sea level. Capitola is built on the beach at sea level without, a lot of awareness of what could happen in the future. The other thing we've done, like Oregon, I think, is encroached on the shoreline. So there were times in the past when the weather was good, we built up dunes, the beach was a little higher. People claimed that land, divided it, built homes on it, but they're almost at sea level. And these are homes that are quite expensive. This happened in the 1983 El Nino with these very high tides combined with very large waves and an El Nino elevated sea level. These are homes that are usually advertised as being on the sand. After that winter, they were on the sand. Here's one that just came out of the paper from that same area a couple of weeks ago. Typically advertises on the sand and steps to the beach. So this is beach level in the summer months, $9.8 million. I don't know if there's full disclosure here by the realtors or not, but this is something we're seeing more and more of, this kind of conflict between people who want to live on the sand and the hazards or risks they face. So this is something that affects both private development, but also public infrastructure. I don't know exactly what happened in January of 2023, but this was sort of the perfect storm that we experienced 40 years earlier in January 1983. And this is from a wave gauge offshore of Santa Cruz, where we had waves, significant wave heights, the average of the highest 1/3 of the waves of 28 feet. And it occurred exactly at the same time as a very high tide. It's predicted to be 6 feet. It was actually 7 feet. So these two together took water into areas where it normally didn't get. This is out on West Cliff. Rhiannon can probably appreciate this. The sea was angry that day. I've never seen anything like this. And we live about 2 blocks from here. You could feel the ground shaking. Sort of this iconic coastal road that people walk and bike and drive on, but it overtopped the road and began to quickly erode the terrace deposits. Here's the bedrock. couple places in particular, and now we're spending about $35 million to try to rebuild this. So what's next? What are options for the future? We just came out with the most recent guidance for California on future sea level rise, kind of with a step-by-step pathway of how we might respond. These are the oldest condominiums on the California coast, and they were all flooded during this last winter. So we don't have too many options, and I don't think it's any different in Oregon than here. There's denial. There's beach nourishment. There's armor of one sort or another. There's now a sort of a new movement for living shorelines or nature-based solutions. And then there's relocation, planned or unplanned retreat. So denial, not very effective. In fact, somebody has put together the 6 stages of climate denial. Sounds like Florida. It's not real. It's not us. It's not that bad. It's too expensive to fix. Aha, here's a solution that actually does nothing. And oh no, now it's too late. You should have warned us earlier. So I think this is something to keep in mind. Beach nourishment is what the Atlantic coast has depended on for decades. They have spent $15 billion and put down 1.5 billion cubic yards of sand. A little in California. It's been very expensive and very short-lived, maybe $1 to $2 million. I'm sorry, 1 to 2 years, but very expensive. We have a high literal drift rate. That sand just doesn't stay there. I've recently sort of done a critique on the global, well, US beach nourishment, looking at how many times some beaches have been nourished, some in Carolina 30 times. In Florida, some have been nourished 50 times. And we are paying for that. Armoring has been the choice of most of California, and I think Oregon historically. For our coast, about 14% of the entire coast has now been armored, but Southern California, about 38%. And we see this from one end of the coast to the other, which we can go from north to south. Not so many people in Humboldt and Del Norte, but by the time we get to Southern California, this is the percent of those shorelines by county that's been armored and the number of miles. So a lot of armor, and we've looked at the impacts of armor. Putting in seawalls and revetments is not without its problems. So I pulled this article off the internet. Neighbors influence coastal landowners' decisions to armor shorelines against erosion. This is for Oregon, and I think it's the impact of your neighbor putting in a wall tends to lead you to put in a wall. So Oregon, much different. A much less developed coast, 6% instead of 13 or 14 in 22 miles. So you are at an early point. Living shorelines has kind of come up recently as a solution, which sounds good because it's living and green. But in fact, if you look at the living shorelines, suitable only for low wave energy environments, suitable for most areas except high wave energy environments. And when I think of the outer coast of Oregon, it's a high wave energy environment. So there's nothing we can plant. We can stick some plants in the dunes, but we cannot plant anything on the shoreline, on the cliffs, that's going to really slow down wave attack. We also have nature-based solutions that really came from the tropics. Mangroves can be very effective, trapping sediment, slowing down erosion if we take care of them. Coral reefs have been very effective. And in wetlands and estuaries, we can have various grasses. But when I look at the California coast, it looks like this. Well, first, we don't have coral reefs and mangroves or these kinds of plants. There's absolutely nothing we can plant here that's living that's going to make a difference. We now have this idea going sort of nationally. Let's put in dunes and we'll plant them. One big storm, the dunes can be eroded overnight. And there's now a number of companies that are kind of capitalizing on this and making, I guess what they're calling nature-based solutions. They're mainly seawalls with these little objects on them that hopefully will allow anemones to grow. So I would say a seawall by any other name is still a seawall. So I've been writing a bit about this. Let's look critically at living shorelines. A lot is being said today about making coastal communities resilient. I am still trying to figure out where is a resilient coastal community and what does that really mean? I think it's important to have some definitions here. So I'll just finish with one statement here. In the long run, there's absolutely nothing we can do to hold back the Pacific Ocean. We can begin to slow climate change, but it really depends on what we mean by the long run. Can we plan for 10 years or 20 years or 50 years? And any protection we put in, anything we build, protection ends somewhere. The seawall will be overtopped or collapse. The riprap will collapse. So one of the things we have to keep in mind is if we look around the planet today, we've got a lot of ice out there that has a high sea level rise equivalent. And if we melt all that ice, we could raise sea level 216 feet. Nobody thinks that's going to happen this year or this century or next, but even 5 feet, 4 feet will have a big impact. At some point, people don't want to hear about this. It will either be managed retreat or it'll be unmanaged retreat. And it's amazing what house movers can move. Okay, I'm going to stop with that. Thank you very much. And happy to answer questions. But we're going to end with this slide.
Thanks so much, Gary, for that great presentation. If anybody has a question, feel free to either pop it in the Q&A box or you can drop it in the chat as well. And thanks everyone for joining us.
I tried to hit 45 minutes so we had some time and it was pretty close.
We've got some kudos in the Q&A box there. And just a reminder, this webinar was recorded, so it will be posted on the Surfrider and Oregon Shores YouTube accounts, and I will also email out the link once that is live.
You
And
never
again,
know. There's no
oh, go ahead.
questions. That it was
Yeah.
either so clear and coherent that nobody had a question, or it was so confusing that people don't know what to ask.
We do have a question in the chat. How long will a riprap revetment last before it is undermined?
Really good question. And like any structure, there's a huge range. There's a number of things, and we've studied coastal protection on the California coast for some time. One of the critical things is what is it sitting on? If you put the rock on a sandy beach in the middle of summer, it's going to be eroded probably and collapse the first winter. If you dig down to what we might think of as the maximum scour depth, that might be 5 or 10 feet down, and then place it on bedrock or an area that hasn't been scoured, and you place big enough rocks at the toe, big rocks landward of that, and then you don't put it at too steep of a slope, you greatly improve your chances of that surviving. So we've seen riprap that's lasted 1 winter and some that have lasted 60 years. So those are some of the important factors: how big the rocks are, how deep you place them, how steep the slope is. And really the same thing applies to seawalls. We've had seawalls that have lasted 6 weeks and some that have lasted a century. So big range in how we construct things and the cost.
Brianna, did you have something to add to that?
I had a question if there is time for another question.
I've got time.
Okay. So in Oregon, we have statewide planning goals, and goal 18 is what dictates what development can and can't happen on our beaches and dunes. And so no riprap or other armoring can be put in place if the property was not developed on or before January 1st of 1975. 19, yes, sorry. And so I was wondering if you could tell us a little bit about how that process looks like in California of is it city or county wide or is it statewide?
Really good question. And I didn't know that was the policy, but everything in California ultimately ends up with the California Coastal Commission. So cities and counties can make decisions on a seawall or construction, but ultimately the Coastal Commission has permit authority and can appeal any of those decisions. And it turns out when the Coastal Act was written back in the 70s, there was some language that wasn't particularly clear that said if an existing structure is threatened, you can apply for a coastal protection permit if you deal with all of the impacts, which means sand supply and so forth. So one would have thought, this went into effect in 1977, January. One might have thought if it said if an existing, actually it said primary structure, it didn't mean a gazebo or a sidewalk. One might have thought existing meant existing when it was written. In subsequent years, lawyers have been very active. People would come in 1995 and say, no, I have an existing house. And they argued for years. And so there was this sort of sliding scale, but with a new director about 4 years ago, they said, no, we're going back to our original language we meant in 1977, January. For those houses that weren't developed yet, they were supposed to have at least a 100-year setback. So in fact, they wouldn't have needed a seawall, but in fact, that wasn't upheld either. So we have very similar sort of restrictions. It is ultimately the State Coastal Commission that has the authority. And some cities and counties will say, we're not even going to bother with it. They're going to go to the Coastal Commission anyway. And the Coastal Commission here, they're tough as nails. There have been periods in the past when there were some developers on there, but now they're all pretty stringent coastal protectionists. So they have really saved the California coast. But for coastal homeowners, they've been challenging.
Thank you. And I misspoke. It was 1977 for us as well, not 1975.
Okay.
Just wanted to clarify that, but thank you, Gary.
Okay, next I will go to Guillermo, who has raised his hand. And just a reminder, I did drop this in the chat as well, but if you would like to ask your question live, just go ahead and raise your hand and I will unmute you. And don't worry, if you put your question in the Q&A box, we will get to those next. Guillermo, go ahead. You are still muted. You have to unmute yourself. There you
Hey,
go.
can you hear me there?
Yes, we can hear you
Yeah.
now.
Thank you, thank you. So, I guess I posted a question on the Q&A, but I am currently working on a project where it's a stream restoration project, but it's a tidal area. It's a tidally influenced creek. It runs through a downtown part of Jacksonville. And it's a road that floods all the time due to normal tides, especially in this time of the year. And when we presented the option to the community, to us was obvious to show the benefits of closing this road. It's a road that's been there. It's probably older than the city, and so the community are used to having it. And they love the project, but they hate the idea of changing their infrastructure, their current street network, etc., even though they have other options. I find that people are reluctant to seeing that sort of change, and I was wondering if you have any ideas on how we should have that conversation with the community, right, with the neighbors, and sometimes even with elected officials. How can we? I don't want to use the word convince them, but how can we have that conversation on the benefits of retreating? Thank you.
Yeah, that's the gazillion-dollar question.
Yeah.
And we are struggling with that in California. And the challenge is clearly, if it's your family home, you're connected to that, you don't want to lose it. Very few homeowners want to retreat, want to move back. Ultimately, they're not going to have a choice. So that's why I say it's either managed or unmanaged. A couple of efforts were started here through our Coastal Commission. So we have, and I don't know if this is the same in Oregon, I don't think so. Each coastal city and county has what they call a local coastal program. And when the Coastal Commission was first established, they requested each city and county to do this. So that set out their guidelines for seawalls, for erosion, for access, and then the Coastal Commission would approve those. But this was back in 1977. Sea level rise wasn't an issue there. Seawalls, erosion. It was about habitat protection and access for the most part. So the language was a little vague. About 3 or 4 years ago, the Coastal Commission requested each city and county to update their local coastal programs and include managed retreat and sea level rise. So most of the communities said, okay, we'll do something. 3 communities said no. One was Imperial Beach on the Mexican border. One was Del Mar in northern San Diego County, very, very wealthy people living on the sand. And one was Pacifica, that's actually lost apartment buildings and other things. So I think what we needed was a dialogue where we're listening to the coastal homeowners and trying to gradually introduce the idea, which I did some of that in here, that, climate change and sea level rise is not an option we get to vote on. And we're in a political climate right now where we obviously have several different perspectives, 2 different perspectives. Climate change is a hoax. And we have to at least appreciate the science. There's a great couple of lines. One is a science communicator that says, the wonderful thing about science is it's true whether or not you believe it. And the other is by another science communicator that says we're all entitled to our own opinions, but not our own facts. So I think it's slowly explaining to the public officials or the homeowners, and we have history. We can see where the coast was 50 years ago and where it is today, recognize that it's eroding, look at the projections of future sea level and larger waves and say, this is inevitable. There are impacts of building coastal protection structures, but at some point, we'd like you to live in your house as long as possible, but at some point, we have to realize that we're going to have to move back. We cannot stop the Pacific Ocean. So I think there's a historical record of change that people need to begin to understand. There's been a couple of proposals to buy out coastal homeowners, and I think a lot of them would love that. But at least in California, and I don't know, I wouldn't guess what this house might cost. Well, it might cost something different now than it might have 20 years earlier. But we've got people in Malibu sitting on the coast that are $10 and $20 million homes. The state of California cannot afford to buy those people out. There are some, a few places where economically disadvantaged people are, and we could afford to buy some of those. And that happened in places in New Jersey after hurricanes, where maybe a house cost $300,000, but not 15 million. So I don't think buyout is probably a realistic future option. Another is buyout and then rent it back. But once the city or county buys it, property taxes end. So there's no more income coming in. And I don't think you could ever pay off a $10 million house with what you could rent it back for in the life of that house. So I think it's a dialogue, an open dialogue, which is easy to say, but we're all in this together. And we can't turn climate change around overnight, which is what we need to do in the long run. But, that's also a giant political mess, depending on who we elect in November. I was going to try to stay out of politics. I hope that helps, Guillermo.
Yes. It definitely does. I think sometimes the science is a little easier than, the natural science is easier than the social science.
Exactly.
Yeah.
Yeah.
Yes. Thank you.
You're welcome.
Next we'll go to Niku.
Hi, can you hear me?
Yes.
Thank you, Dr. Griggs, for that great talk. My question was, are there any interesting labs, state, or government groups that you're currently collaborating with to monitor these coastal changes? Like, are there any things that are making you excited the most right now? Area.
I get excited every day when I get up. Going into the classroom, having people like Rhiannon in your classroom. And again, I just started my 57th year of teaching, and everybody says, why don't you retire? And I said, I don't want to retire. I really love what I do, and there's so many more things we still need to do. But so I work at the state level, and there's actually something called, well, there's 3 organizations, one called the California Ocean Protection Council, and that's a group of officials and some members of the public that deal with funding, for example, to study coastal issues and resilience and responding to sea level rise. There's the Ocean Protection Council Science Advisory Team, which I was on for 15 years, that is a group of scientists, mostly from California, that helps advise the Ocean Protection Council. Then there's the third group, which Oregon has now created, called the California Ocean Sciences Trust. And now there's the Oregon Ocean Science Trust. In fact, a woman who was on our trust, who's still on the trust, Karina Nielsen, is now the, she may be listening tonight, is now the head of Oregon Sea Grant. And she, I think, has begun that group. So we deal with sort of connecting policy with science, doing studies like this recent one with the Ocean Protection Council on projecting California's sea level rise and these extreme events into the future, because any individual city and county can't really do that very well. But at the state level, we can put out policies and guidance. We're dealing with other things like, ocean acidification and overfishing, but California is, I think, because we're the most populated state, we have a very long coastline. Without bragging, we're the 5th biggest economy in the world. So I think things that happen in California, and we're also, probably know, like Oregon, a very progressive state. So I think the things that come out of Oregon are often looked at by other states and say, well, let's learn from what they have done. So I'm excited to be in California and be in a state where we have progressive leaders, a series of organizations like the California Coastal Commission, because it's hard as one individual to make a lot of progress. But when you get a number of politicians seeing sort of what's the writing on the wall, I think we've made some real progress. Are you shaking your head, Rhiannon?
No, sorry, just coughing.
No, that was a good question, Niku.
Great. Moving over to the Q&A box, we'll start at the top. Diana Turner wants to know if you are aware of the clay burrito installation planted with hooker willows that is protecting 4 lots on the shore of Cannon Beach.
I am not, and I don't keep up with Oregon regularly. We have 1,100 miles of California coast it's hard to keep up with. But I do know in Hawaii, they call them Hawaiian burritos, and they're these sandbags. There's companies that make these sandbags called long yard tubes that you can roll out of different diameters and stack them up, that are thought of as sort of soft. They're not cheap, and they can be undermined. They're easy to vandalize. People have taken a knife and cut them. So I don't know about Cannon Beach, but they've been used in a few places, but they've never really taken off, I think, because they're vulnerable to undermining and vandalism. And again, they're not cheap either.
Diana just raised her hand, so go ahead, Diana, if you want to ask another question.
Hi there. Thanks for your answer. I work with a group called Friends of the Dunes at Cannon Beach, and we advocate for the shoreline there. And actually, it's interesting to hear the experience that you know of in Hawaii. We have 5 lots that have these clay burritos, and 4 of them are over 2 decades old, and they have not had maintenance, and they are actually less expensive than their riprap neighbors installation. So I really wish that there was, and there is becoming more of an awareness of these type of structures and revetments and the success that is there. But honestly, even speaking to Oregon Parks and Rec, they say, I said, are there more? You know, I only found out about one because it was called out in the new, only a couple years old guidebook on dune management. And they couldn't answer that question. Nobody knows. Nobody has done a catalog of that. But now Oregon State does have a doctoral student working on that and tracking it. The one who made the guidebook. And interestingly, the 5th one that is only a couple years old has not been successful. It has been planted with dune grass, and there's been a lab experiment at Oregon State looking at the effectiveness of dune grass, and actually planting with just dune grass is less effective than leaving the dune bare. So what we have on that 5th lot, the newest one, is a situation where the homeowner very much wants riprap, and because, as Rhiannon can attest, the process to get riprap requires an attempt at these nature-based solutions. So when people are incentivized to have failure, then they're planting with, you know, dune grass rather than the hooker willow that has been successful. But I just wanted to point that out for you to maybe you would want to learn a little bit more about that. And
Yeah, I'll look into that. I hadn't heard about these clay burritos. I don't know what that means. They're filled with clay, or
Correct.
there's clay on top of them that they plan on, or
filled with clay and then planted with primarily hooker willows and then European beach grass. In Cannon Beach, the primary beach grass at this point is American beach grass, but there's also been a hybridization between the two. So people are you know, wondering what that hybrid will end up doing and affect how it will affect the dunes.
right.
There is wear at the toe on all of these, of course. They're over 20 years old, but there are no permits on file for maintenance on them either. So just like you would expect a shoe to have some wear on the toe after 20 years, these do. So it's something that's important for my group and for me, because we're, you know, there is now this awareness of sea level rise. And so what that's led to is this rush to riprap. And so
Right.
we want people to know about the success of these other techniques. I also wanted to know if you knew about a PhD dissertation out of Oregon State by Meredith Leong, Scholastic Coastal Futures Using Statistical Techniques to Assess and Inform Adaptation to Chronic Coastal Hazards Under a Changing Climate. That's a mouthful.
That's a mouthful. I do not know about that, but I think your point is a good one, that some things can be effective, and some of the factors that might affect why those have been there for, you know, 20 years. How far back on the beach were they? You know, how often are they hit by really large waves and high tides? Because we have structures that have been lasted for a century, and they're way back on the back beach, so they don't get hit that often. And then if they were placed deep enough so the sand doesn't erode out from underneath them, they could be effective. But the one that's failed maybe because was on a, you know, placed on sand that eroded, a number of reasons why it might collapse. So there are, you know, local factors that could make a difference between success and failure. We've looked at the effect of coastal protection structures on beaches, and there's no question that there are visual impacts. There's a loss of sand that would have eroded out of the bluff, so sand doesn't get to the beach, and the Coastal Commission here is very concerned. You can cut off access, horizontal access, because there was a beach there and now there's a pile of something. And then probably the most important is what we call passive erosion, that with nothing in the way and sea level continues to rise, the shoreline, the dunes, the bluff will just keep retreating, and we will still have a beach there. It'll just be further inland. But once we fix the position of the shoreline, whether it's a clay burrito or a rock revetment or a seawall, gradually that beach is going to get drowned or flooded. So that's one of the long-term effects. And it's really a function of, you know, how fast sea level rises in the future, and then how many big storms with, you know, high tides we get. But again, I will say, not in opposition to what you pointed out, but everything we do to try to stabilize the shoreline, whether it's Oregon or California, is a Band-Aid. It's a Band-Aid of a different size, of a different cost, and a different sort of long-term effectiveness. But in the long run, we put so much carbon dioxide in the atmosphere, we have a certain amount of warming and sea level rise already built in. And it's something like 5 more feet, I would say all bets are off everywhere. I don't mean to be totally negative, but I mean, that's the reality of what's happening. So, you know, the picture on the screen is an example of one type of support that was lost. But I only wish I could be here in 50 years, but I don't think I'm going to make it. Thank you, Diana.
Yeah, I should have mentioned that they're classified as high wave energy locations, low lying, so.
Next, I see Lori McRae put a question in the Q&A box, and you have your hand up. So go ahead, Lori.
Thank you. This was a great discussion. I live in Manzanita on the Oregon coast. And I was actually involved in the first round of LCDC planning in the 70s, mostly looking at coastal and estuary goals. And so these questions were sort of this run-on thinking that I was doing. Obviously, the most effective solution is in wise shoreline planning. And it sounds like we can't engineer our way out of this. So I'm wondering, similar to what's happening in Florida and in some areas of California with wildfires, will the insurance company, since land use planning doesn't always have the teeth that people's wallets have when they're emptying, is this something that we can look forward to in terms of rising insurance rates, eventually pricing people out of wanting to build in these areas?
No, good point, which we haven't touched on, but we know along the Atlantic coast that a number of insurance companies are pulling out of that area because they've been damaged by hurricanes so many times. They're not going to insure it anymore. And if you can't get insurance, you can't get a mortgage.
Right.
In California, it's been the fires, but the two biggest companies, I want to say Allstate and Farmers, I'm not sure, they have basically blanket canceled policies. Some have been raised. We live in the middle of the city, and the company we were with, Nationwide, just decided about 2 months ago, we're going to terminate your house insurance. We're not in the forest. Terminate your house insurance in August and your car insurance in September. So we found another insurance company, but it wasn't because of the risk. It's just that they don't want to deal with California. And as much as we'd like to believe otherwise, insurance companies aren't out to help us. They're companies that make money. So they want to make sure their premiums cover the cost of their losses. And when you get a fire that burns 800 homes, many people may know, but may not, that they're actually reinsurance companies that insure the insurance companies. So there's a hesitancy there. And I think that economic sort of solution may be ultimately what happens on the coast. Now, we have a lot of really wealthy tech people that have bought these oceanfront homes as second homes. If you're worth $500 million, What's a $10 million house? And if something happens, I'll buy another one. That's one piece of it. But, you know, all houses and all houses aren't owned by, you know, these expensive or very, very wealthy tech people. So I think that may be the line that separates, you know, new construction or new construction on the edge. And I do a fair amount of consulting for some of those people and say, you know, I would not live there. And I've had people say, thank you. You just saved me $3 million. But there's a lot of houses that have been there for a long time in the family that, you know, they don't want to give up, but it will happen. And maybe insurance will be the straw that broke the camel's back.
Thank you.
Allison and John both had a question. I think Allison's question is about managed retreat as well. She's wondering if there are any efforts in the US or other countries to do full community removals. And then John was wondering about what policies might foster planned retreats rather than waiting until something happens.
So the first one, there's actually a case on the French coast where this development was behind some dunes very low. It was totally wiped out. And it was is France run by a president? He just ordered it to be abandoned. They took out the whole city, the whole town after this major hurricane. There's an interesting, and I have written about there's a part of the coast of UK, the Yorkshire coast, and it looks about like the coast in this picture. Can you guys still see the slide up? Is it still up there? It's glacial clay left from when the glaciers were there. And I came across this reference from 1912, and it's called Lost Towns of the Yorkshire Coast. And they have plotted the position of the coast for 2,000 years since the Romans were there. And there's 28 villages that have been completely lost. So when we drove in that area, I was surprised. It retreats on average about 6 feet per year. Most of the land is sheep pasture, but what they have done, and again, I wrote an article about this, is they put in what they call caravan parks. So they're mobile home parks, and they're both people who actually have a summer place there, or they bring their mobile home in. You get a concrete pad and water and electricity and sewer. And as the bluff gets close to you, they just hook them up to a truck and they go to the back of the line and the next row gets front row place for 5 years. So I would call that resilient. They just move everything, but not everybody's house is on wheels. So I did another paper, and I could, you know, connect you to this. It's called Lost Neighborhoods of the California Coast. And so I looked at all the places where we've moved back. A couple are now stretches of Coastal Highway 1, State Highway 1, one down in that San Simeon, one in north of San Francisco, where they actually moved the highway in. They realized they couldn't fight it. And there's a number of neighborhoods where Capitola Depot Hill, other places where neighborhoods have been completely lost. So it wasn't so much planned retreat as much as it was they were no longer safe to occupy. And this is what happened with these apartments in Pacifica that I started a picture with those. County building inspectors, red tags, it says not safe to occupy. The bluff drops 80 feet down. So there are examples. We also put out a paper a couple of years ago looking at these around the state, more of them, different situations. So there is work that's been done that I would be glad to provide you with. In each case, I think it's still been sort of piecemeal when they had to do something, rather than, except this case in France, rather than some city or county being successful in legislating that. And you're barking up against a lot of wealthy people and a lot of people with investment in their whole lives on the coast. So that's not an easy group to oppose. Good question.
I think that segues nicely into Kristen's question, wondering what can be done to prevent wealthy coastal landowners from violating Oregon's beach planning goals and investing in shore armoring on their properties.
So apparently that happens. Because here, again, with the statewide coastal commission, if you're in violation, they notice you and you could get fined $10,000 a day. So that's been enough of a disincentive. And there's also, it's like building a house without a building permit. Contractors are on notice. If you're somebody who delivers rock, your license can be taken away as a contractor that's doing something illegal. So there's two sort of built-in barriers there to that happening, unless the wealthy person owns the contracting company. But I think that's not what has happened in Malibu. Is they've tried to keep people off of their beaches, and that's been overturned, and we provide access ways. So there are ways that it's been dealt with here.
Rhiannon, do you have more to add to that?
Yeah, thank you. And we have similar processes here as well. Oregon Parks and Recs, their Ocean Shores division, they are in charge of permitting all of our armoring. And if something does come to their attention, of either through their beach rangers looking up and down the coast, or somebody, a citizen, alerting them of that, then they do have fines that they can implement as well too. And so they do have a full process, including a notice of violation. And then if the project or the armoring is not removed, then they can pursue those avenues as well too. And so we do try to keep a pretty vigilant watch on our shores as well too. And especially moving forward, that's kind of OPRD and DLCD's path.
Eva has asked two questions. One, she wants to know how sea level rise might impact rocky habitats and other marine ecosystems on the Oregon coast over time. I think that might be a topic for a future webinar. And then if anyone has anything to add on that, though, go ahead. And then her other question, your graphic about how sea level rise varies based on the location on the coast was interesting. It seems like some places farther west has less sea level rise than places farther east on the coast. Are those distinctions dramatic enough that more intervention should be made in places like Tillamook rather than Port Orford?
Yeah, good observation. I don't think it's east-west. I think it's north-south. So as subduction occurs and this underlying plate is pushing under, it's sort of warping the coastline up. So the part that's being pushed down is arching up the shoreline. But if you look at the sea level rise rates and elevations along the coast, Paul Komar did something on this a number of years ago. You can see there's kind of a wave of uplift and down warping that's been north and south along the coast. There's more data than just those 4 or 5 tide stations. There's a lot of geodetic measurements that can tell whether the coast is coming up and down. So again, those rates, the rates of sea level rise are millimeters per year. We have a big El Nino where raise sea level 6 feet and waves come in at high tide. So I think in the next 50 years, those sea level rise rates are going to be relatively unimportant in the big picture. The really big picture is when that plate finally ruptures, the offshore air is going to come up, but the shoreline is going to go down. And that's when those ghost forests were created. So when that happens, anybody living along the shoreline is probably going to see the land subside. And people have talked about 1 meter or 2. The problem is we cannot predict when that earthquake is going to occur. And I don't know what we would do if we could predict. Do we start moving our houses now? We live there as long as we can, because when you're directly on the shoreline and that magnitude 9 earthquakes occurs, that land's going to move virtually instantaneously. And that tsunami is going to come on shore within probably 5 or 10 or 15 minutes, which you see those lovely signs, and we have them that says tsunami warning zone. If the ground starts to shake, there's a person climbing up this hill, but you may not be next to an area that's high enough to get away from. So that's an incredible challenge. And I'm going to say future sea level rise because we built almost our whole civilization along shorelines when in fact sea level was nearly stable, sea level rise may be the biggest challenge human civilization has ever had to face. COVID's going away. Politicians are going to go away, but sea level is going to continue for centuries. And what do you do with the Miamis and the New York Cities and the Portlands and the Shanghai and the Guangzhou and the Lagos, Nigeria, and Dhaka and Singapore? They're all mega cities on the coast. And how do you move Miami? That's a huge problem. Maybe you just concrete in the first 2 floors and everybody goes up. I mean, I say that facetiously, but quite frankly, we don't have an answer. And I'm glad I don't live there. We're 2 blocks inland, about 30 feet above sea level. I feel pretty comfortable.
I think that segues nicely into Betsy's question. We've been warning about climate change and sea level rise for decades now, and still so many people don't care or believe it can affect them. I know I'm burned out with trying to explain it to people. How about you? How do you find the inspiration to continue with this?
The hardest questions are always the last. And my first response say, next question, please. I feel like I kind of won the genetic lottery. I get up every morning really excited about what I'm doing. And I also feel as a teacher, you have to have hope. You have to be positive. I also happen to have, children and grandchildren. And I think for them, we have to have hope for the future. So sometimes, it takes a long time. It's incremental. Someone once called this sober optimism. And aggressive incrementalism. You just keep taking it one step at a time, but you stay aggressive. So certainly communication is challenging. And maybe 10 years ago when I go to groups and talk about sea level rise, there'd be some person out there say, don't you know that's a hoax? More recently, that hasn't happened. So I think that thing I showed on the list of stages of climate change denial, we've kind of moved through that. And I think people now, except for I've a couple of times been called by CNN on claims or statements by Donald Trump about sea level rise. And one of them was, it's going to rise 1/8 of an inch in the next 497 years. They said, well, is there any truth to that? And I said, absolutely not. He has no idea what he's talking about. We can measure it. It's rising 1/8 every 9 months. So one thing is to be able to explain it in a non-confrontational way. But I think clearly, sadly, we have, at least in California, maybe Oregon, we kind of live in a bubble. And there's lots of people, almost half of the population, that is either doesn't want to listen to science or is pretty set in their ways and their beliefs. And I don't know what it would take, except maybe, what could happen more than these 2 hurricanes in a row in Florida that would cause those people to think maybe there is something to this. Because, the organizations that work with climate and sea level say, that those events were definitely made worse by a warmer ocean, period. So, but you kind of have to pick your battles carefully and you can't do it all in one day. But so far, I see people like Rhiannon out there and I say, well, it was worth it. One of my students, Rhiannon, you may know, Kathy Sullivan, took my class, changed her major, became an oceanographer, was space shuttle astronaut, the first American woman to walk in space. She then became the assistant administrator of NOAA, and then the administrator of NOAA, the highest ranking oceanographer in the country. And now she's retired. She just went down 2 years ago to the bottom of the Marianas Trench. She's the only woman in the history of the planet that's gone into space and down the bottom of the ocean, the deepest spot in the ocean, the first woman. So she's still making waves. So we just have to keep plugging away with aggressive incrementalism and sober optimism. I hope that helps.
And then I think the last question for tonight will go with John Morris. At a number of river mouths on the Oregon coast, there are sand spits where the river parallels the shoreline before emerging out the ocean. The sand spits are currently made up of dunes covered in European beach grass, which was introduced to stabilize the dunes. I understand that the dunes migrated before stabilization. Are the sand spits themselves at risk of totally disappearing as sea level and storm surge severity rises? What is a possible timeline?
Next question. So if we we realize sea level is getting higher and the rate is increasing and waves are getting larger. In the long run, it really depends on what the time frame is. Just like those sand spits existed 10,000 years ago offshore someplace, they're going to continue to migrate. So if we don't cut off the sand supply, those spits and dunes will probably migrate landward over time. In really big storms, they may be completely overwashed. And I would say the dunes are helping, the vegetation's helping now. But if the waves get large enough and they happen frequently enough, dunes can't hold back major storms and they'll regrow again. But we have to look at that long-term trend of sea level rise. And maybe it's one winter, maybe it's 10 years, maybe it's 20 years, but that's difficult to state with any assurance because we don't know what the weather's going to be. We know El Niños are really damaging, and despite our ability to send a spaceship to Mars and drive a little car around, we do not know why we have El Niños. We know they happen every 3 to 7 years. We do not know why they occur. We know what happens, but why? So I say that as an encouragement to students today that there's still plenty of problems we have not solved and plenty of things we need to still work on. So thank you for the chance to talk to you all tonight. I hope that was useful. Try to stay positive in the midst of chaos.
Yeah, thank you so much for joining us. And then I'll just plug, we have 2 more webinars coming up this year. We'll be welcoming Jonathan Allen on November 21st. And then in December, on December 4th, we'll have Peter Ruggiero here. So that link will take you to where you can find those webinars. I also will put a link in the chat where you can find those webinars and RSVP. We kind of took a global perspective today, and we'll just continue taking it down to the West Coast and then to Oregon. And then we'll be doing more topics in 2025, and we'll continue our webinar series then. So yeah, thank you all so much for joining us. I hope to see you again next month at the next webinar. And thank you so much, Gary.
Yeah, thanks all of you. Rhiannon, great to see you again.
Thanks,
And
Gary. It's
Phil-
good to see you. Thank you, everyone.
Okay.